With Solid Edge, you can enhance your product design process while automating and simplifying workflows to maximize productivity. Locating just the right part has never been easier. Search wildcards are supported in parts libraries, model view palettes, and the assembly pathfinder. These wildcards provide flexibility when searching, allowing you to match and retrieve parts based on partial or uncertain terms or variations in spelling in your query. Search results display subassemblies and parts in various shades of green for easy identification. With expanded family of parts options, flat patterns can now be included while working on sheet metal parts, containing all the information you need to create drawings or annotations. Once we define the new members, we can see options to capture sketches, file properties, and variables. Further enhancements to family of parts include the ability to set individual material properties per member, as well as control the suppression states of sketches and etches. Selecting a specific member shows the material change alongside different etches specific to each member. Greater control of selecting objects has been added with the polygon and lasso selection fence options. This makes many common workflows much easier, like resizing holes. Using the lasso selection option, we'll select the desired holes and change the size with ease. Polygon and lasso selections are available within the part, assembly, draft, and subdivision modeling environments. Many designs require handed parts. These symmetrically opposite parts are identical, mirrored copies of one another. A new streamlined workflow makes it easier and faster to create these left-right-handed parts that can remain associative to the original part if needed. With the selection of a mirror plane and quick save, our new handed part is immediately available for use. And the best part of using the Save as Mirrored command? All the features used for creating the sheet metal part are carried over, minimizing errors when making downstream design changes. The display of bend center lines in the flat pattern environment is now supported within the sheet metal environment. Color coding defines the bend direction. Up bends are displayed in blue and down bends in green. The color and style of center lines can be easily modified to suit your company's standards. In Solid Edge Express Route, multiple pipes and tubes can now be automatically trimmed with the help of the trim command. In this example, after turning on the clipping planes, we can see there is overlap between the main tube and the 3 cleaning tubes. We can trim these tubes so they join together seamlessly with just a few simple clicks. By selecting the primary and secondary tubes, the Trim Tubes command intelligently cuts holes in the main tube to the outside diameter of the secondary tubes and trims the 3 cleaning tubes to fit. Another new capability in Solid Edge is the Recent Documents Preview, where we can easily select the part we'd like to work on without leaving the design environment, saving time and energy. This sheet metal part requires some modification, the addition of several punch slots. 7 construction bodies have been placed in the sheet metal part to represent the punches used to remove the material. Using the Subtract command, we can select the main target body and then quickly and easily choose the solid bodies as the tool step, all within the same window. Unwanted regions left behind as a result of the subtract operation, or disjoint regions, can be intelligently identified and automatically removed. Hiding the construction bodies, we can see all the internal disjoint regions within the sheet metal part have been removed. And that's just another example of how you can enhance your design process and simplify workflows with Solid Edge and unleash the power of intelligent product design. Maximize productivity and smarten your design process with new artificial intelligence and user-driven capabilities in Solid Edge. Let's explore these enhancements with Solid Edge customer Subfina's Race Neo automated super finishing machine. We'll focus on the polishing tool and fixture for these high-performance motorsport roller bearings. By expanding the assembly features in Pathfinder, we notice a hole and cutouts were added at the assembly level and need to be completed with a rounded chamfer. This can be solved by reordering the assembly features with the new, simple, drag-and-drop process that resembles reordering part features. This allows you to move the parent and child features together, keeping your model organized. The polishing tool has a 3D printed component that requires 2 holes to be added. To ensure appropriate fit and assembly for the 3D printed threads, we can define additional clearance values using the hole command. These values can be input as either a percentage or absolute value. By selecting percentage, the internal diameter will increase by a percentage of the nominal diameter, which is seen in relation to the sketch. We can also switch the option to absolute to enter a specific measurement. To finish off the assembly, a polishing tool can be added to the bottom of the cylinder. By adding a mate, planar align, and axial align with the hole, the component now matches the main assembly. Using the new Resolve Relationship Conflict dialog box, we can easily identify and suppress conflicting relationships to resolve them swiftly. This new tool helps streamline part placement and assembly relationships. Hovering over listed conflicting relationships in the dialog highlights them graphically. One or more relationships can be suppressed at a time until the requested relationship turns green. The improved Replace Part command leverages artificial intelligence to predict solutions for replacing a single component occurrence constrained to a neighboring component within an assembly. The AI predictions support planar and axial align relationships and present the solutions in a secondary dialog, allowing users to preview and select the most suitable option for executing the replacement. Enhancements to the variable table filters provide quick and easy access to filter options, resulting in an efficient experience that reduces both time and mouse clicks. The variable table can be used to reposition the polishing tools and ensure they will contact the bearing in the correct locations. With numerous variables in the assembly, the results can be filtered by user-created, system-created, or both. Another great option for filtering is to only view variables relative to selected components. This makes it easy to find the swivel angle variable and make a change. The vertical height of the polishing tool can also be changed by updating the NC axis value. Continuing to smarten your design process while maximizing productivity with AI and user-driven enhancements. Solid Edge. Unleash the power of intelligent product design.
Intelligently define and annotate 3D models while better conveying design intent for downstream manufacturing processes with the new Solid Edge Advanced PMI and model-based definition capabilities. The improved Auto Dimension tool in Solid Edge Advanced PMI can be used with 1 or 2 datums for more freedom while automatically dimensioning turned parts. Using the new Recent Documents preview will open another bracket that's been partially dimensioned. With the new Dimension Checker command, quickly and easily identify the constraint status of features and parts. The model is automatically color-coded with feature IDs, informing you of the constraint status of features and if they lack any tolerance information. In this example, the slot and holes are under constraint, and as a dimension is missing a tolerance value. By adding the necessary tolerance, Dimension Checker will instantly update with the new status, and the Auto Dimension tool will automatically add the missing location dimensions for the holes, improving creation speed. The improved Auto Dimension tool also includes stack dimensions and callouts for slot and oval cutouts. Features chosen in the selected primary, secondary, and tertiary planes can be auto-dimensioned instantly, and you can now automatically dimension location and size callouts for your created slot and oval cutouts. The Common Model Views command allows users to create common model views automatically with the existing PMI. With the required view selected, Solid Edge automates view creation. Applying section views to a model view is easy with the enhanced vertical command bar that can be launched from the Model View palette. These easy-to-use command bars make editing model views simple, like adjusting the render mode as we see here. To clean up the PMI dimensions, we'll run the enhanced Arrange Dimensions command, which provides the ability to arrange coordinate dimensions alongside the linear dimensions. The Update Model Views automatically updates all model views when the model changes or PMI is added or removed. Auxiliary plane indicators can be added, giving you more freedom to annotate the models based on ISO or DIN standards. Convey design intent for downstream manufacturing processes with 3D PDFs that can be published using templates. You can now export PMI views with selected section views and render styles to the 3D PDF, including those created with single planes, to streamline the delivery of relevant design information. With new PMI face association, parent faces and section views are automatically highlighted when they are selected in the 3D PDF. For assemblies, 3D PDF documents can contain an interactive parts list. On selection, parts are highlighted in the list and graphics window. Associative properties such as author can also be included. STEP, AP242, and JT files can also be generated and added as attachments within the 3D PDF. Interoperability enhancements allow your Solid Edge files to look the same when opened in other Siemens Accelerated Portfolio solutions such as NX. The improved PMI association and support for various PMI data provide increased connectivity for downstream applications. Visit the Discovery Center in Solid Edge to get your free 30-day trial for Solid Edge Advanced PMI. Trials for other add-on products are also available. With Solid Edge Advanced PMI and model-based definition, you can intelligently define and annotate 3D models, better convey design intent for downstream manufacturing processes, and unleash the power of intelligent design. Solid Edge continues to improve your product design, bringing you real-time product configuration. With new enhancements in Solid Edge Design Configurator, you can automate your designs, reduce product development time, and shorten order lead times and time to market. New pre-configured models allow you to quickly and easily place intelligent datasets for ladders, conveyors, and enclosures directly into your design. The ability to customize fully configured sub-assemblies inside the main assembly helps simplify workflows and improve productivity. In this example, a fully configured ladder assembly is being modified directly within the main assembly environment. There's no need to go back to the sub-assemblies and configure them individually, saving you time and energy. A secondary ladder is needed to complete our design. With the new call subassembly command alongside the place part model and loop action commands, full subassemblies can be placed and configured right on the spot to help boost design speed. After placing the ladder, we can customize the length. Due to the intelligent models rules, a second section and a middle hoop are also added. To finish up the assembly, we need to add a final cabinet. The cabinet can quickly be customized inside the main assembly with the necessary dimensions and colors to fit our needs. With access to fully configured datasets such as ladders and cabinets, it has never been easier for customers to get started with Solid Edge Design Configurator. A new workflow model action category in Solid Edge Design Configurator allows users more freedom for grouping model actions and looping. Using the new workflow model actions, brand new assembly lines can quickly be built with ease. Here, base conveyors and other necessary components are being added to create the new assembly lines. Solid Edge Design Configurator can automatically calculate the number of conveyors and other components needed to match user specification. By defining the length, the software automatically determines the number of conveyors needed within the specified distance to complete the line. With the last machine added, the new assembly line is finalized and ready to be used. The new ability to read from Excel files and external databases for input data and model actions allows you to automatically complete assembly lines at a fraction of the time. By reading the necessary conveyor placement data from an Excel file, the software instantly configures and completes the assembly line with just one click. Solid Edge Design Configurator helps automate your designs, reduce product development time, shorten order lead times and time to market, and unleash the power of intelligent product design. New to the Solid Edge portfolio, Solid Edge Design Configurator Connect, a user-friendly web-based solution that delivers instant online product configuration, allowing your customers to quickly configure a product that meets their specific requirements. Solid Edge Design Configurator Connect enables you to connect your engineering processes with sales and marketing, streamlining design workflows while automatically generating sales documentation. We can first start by making a new catalog inside Solid Edge Design Configurator Connect for our Sauna product line and customize it with the necessary details such as currency and dates. Catalog items can easily be created with important details, including price, description, part number, category, family, discount, quantity, and images. The ability to import Excel files allows you to automatically link specific details from the file with your product line using Solid Edge Design Configurator Connect. Once a catalog is created, the web configuration begins as you import the rules and fields straight from your configured assembly to the browser. Forms can be easily configured for facilitating sales processes. In this scenario, we will define a master form called Customer Info and customize it with the necessary icon. Secondary forms and fields can help when gathering the required sales information. An offer info page and customer page, along with the fields for offer ID, dates, customer name, and address, can be configured to facilitate the sales process. Solid Edge Design Configurator Connect empowers your sales team to configure, price, and deliver customized quotes to accelerate sales, build trust, and connect directly with your customers. Our sauna can now be fully configured online in Solid Edge Design Configurator Connect with the options picked by the customer. A bill of materials can automatically be generated from the configured model, and sales documentation, including sales quotes, can be automatically generated as well. In this case, a unit price is provided for the customer from the bill of materials and catalog information. Solid Edge Design Configurator Connect is the perfect tool to deliver instant online product configuration, streamline design workflows, automatically generate sales documentation, and unleash the power of intelligent product design. Increase your simulation speed, performance, and reliability with new enhancements in Solid Edge Simulation. Instantly import solid temperature results from SimCenter Flow EFD for Solid Edge into a static simulation study with the new Import Solid Temperature command in Solid Edge Simulation. In this example, the results of a FlowEFD simulation in a heat exchanger and the temperature distribution of the fluid flow on the parts are shown here. Switching to solid edge simulation, we already have a study created with all constraints but without any loads. Using the new import solid temperature command, we can set the load for our simulation study and start the solve. The solid edge simulation study processes the results from FlowEFD and solves the calculation. Viewing the results, we see high stresses in the parts as a result of the temperature loads. Interoperability between solid edge simulation and SimCenter FlowEFD for solid edge enables you to find the thermal stresses and deformation in solids, helping understand part behavior and avoid failures long before real products are manufactured. The option to apply force to any given point in solid edge simulation grants you greater control and flexibility in your simulation studies. In this example, a study has been created to show what happens when the component is put under an internal pressure. To run further analysis and determine additional loads, we will define an additional sketch point to add force to. The user-defined point option allows you to select any 2D or 3D point on the component and apply a specific force. We'll set the force direction, solve the study, and then review the results. The enhanced mesh quality checks in solid edge simulation can automatically analyze and identify poor quality areas in complex mesh models. The check quality command instantly identifies and highlights the poor quality areas in the generated mesh. With the intelligent mesh quality checks, you can easily find the problematic areas in the mesh and fix them early on in your workflow, significantly decreasing errors. Continue to increase your simulation speed, meshing performance, and reliability with solid edge simulation and unleash the power of intelligent product design. Streamline your simulation workflows with enhanced structural analysis, electronic components, and improved meshing performance in SimCenter FlowEFD for solid edge. FlowEFD has added the option of IGBTs, or insulated gate bipolar transistors, within the engineering database, where you can create your own libraries. Here we can define the thermal resistances from the junction to top and bottom, and then a series of current voltage charts at different temperature values. In this example, the instance of IGBT can easily be added to our model. Simply start by selecting the mode and top face, apply the desired IGBT from the library, specify the voltage, and define any analysis goals that are required. After running the analysis, the resulting parameters can easily and quickly be reviewed from the analysis goals or from the callouts and plots in the graphics area. SimCenter FlowEFD for solid edge can instantly connect with SimCenter 3D Nash Transolver, granting you the ability to access the nonlinear functionality at any time. With just a few clicks, you can easily couple a thermal analysis in your FlowEFD project with the nonlinear structure analysis provided by the SimCenter Nash Transolver. A DAT file is automatically generated by SimCenter FlowEFD for solid edge, which starts the SimCenter Nash Transolver through a command line. Once the SimCenter Nash Transolver finishes the processing, the results are automatically imported back to FlowEFD and can be viewed with your thermal analysis. You can set up an analysis, run the solver, and process the results all within the FlowEFD window and without ever exporting or importing the files. You can also change the geometry and analysis parameters for recalculation and optimization of the coupled analysis within the same window to ensure high-quality analysis and simulations. With SimCenter FlowEFD for solid edge, you can create tolerance-based contacts in your assembly, such as a gap between contacting surfaces that can arise from a non-accurate design. Here we can see that there is an overlapping region and a gap within the ball joint. By selecting the two relevant bodies, FlowEFD automatically identifies the contacting elements using user-defined tolerance values. The results of the model frequency analysis are shown once the analysis is run, ensuring accurate and reliable simulations and meshing. With enhanced structural analysis, electronic components, and improved meshing performance, SimCenter FlowEFD for solid edge streamlines your simulation workflows while helping you unleash the power of intelligent product design.
Solid Edge CAM Pro improves productivity by enabling artificial intelligence to present the machining options that are used most frequently with AI-assisted operation editing. The prediction node will guide you through the operation editing process. Suggestions will be made based on the machining application and your programming style. Over time, the prediction tab will contain the items you most frequently edit, making it the go-to spot in the operation. No more hunting for options, as the AI assistance is customized for each user based on your preferences. With auto-generate for simple turning operations and certain 2.5-axis operations, you no longer have to generate the operation. As soon as enough parameters are available to calculate the toolpath, Solid Edge CAM Pro takes care of it. This makes NC programming faster, allowing you to review the results quicker. Similarly, any changes that require recomputation are automatically performed. See the latest results as soon as the parameters are changed. Prime turning by Sandvik increases productivity by removing more material in a shorter amount of time, enabling faster speed and increased tool life. Using either Sandvik Prime Turn A or B turning tools, we can quickly, efficiently, and safely remove the material from this undercut. Notice how smooth the entrance and exits are, which produces less stress during the cutting and helps the inserts last longer. 3D adaptive roughing provides the most efficient rough machining possible. It reliably and dynamically checks for tool holder collision when the tool moves within a region or across multiple regions. Toolpath generation is faster, bottom-up cutting has been enhanced, and a top-off flat faces option has been added for faster throughput. The Cloud Connect tool library, as the name implies, stores cutting tools in the cloud database for easy access. Tools and holding devices can be easily searched, downloaded, and modified. Immediate access to cutting tool vendors is also available from the same location. Generate toolpaths on flat surfaces with complex shapes using the face mill mid-pass operation. This feature, perfect for the milling of casted flanges or any other oddly shaped flat surface, automatically calculates the midline distance between the edges of a face and places a toolpath on it. For users that desire the cutter to be off-center of the flange, the operation can also create a toolpath along a shape described as the convex hull of the face. The face mill mid-pass operation can greatly improve productivity for this type of machining, eliminating the need to manually create a boundary line for the cutter to follow. This allows you to create the operation in minutes as opposed to hours. Save your in-process workpieces as faceted bodies in separate files. These models can be used for future machining operations, the creation of manufacturing planning operations, or the construction of secondary machining fixtures and jigs. These in-process workpieces can be saved at any stage during the machining process, even in the middle of an operation. Turn milling is designed to easily machine symmetric and eccentric cylindrical surfaces with high surface quality, precision, and high cutting volume. An operation subtype in the rotary milling template, turn milling is used to pre-cut cylindrical parts before finish machining with other rotary milling operation subtypes. Solid Edge CAM Pro provides cutting-edge updates that accelerate machining while bringing the power of artificial intelligence and the cloud to your machining processes.